Hi, my name is Manish Gupta, and in this video, I'm going to talk about researching and revising using RARR. So let's get started. What is RARR, right? So it stands for Retrofit Attribution using Research and Revision. It is a way to reduce unsupported or misleading content from large language models. Large language models have been notorious for producing hallucinatory text. How can you reduce these hallucinations or unsupported or misleading content? Right? So on the right side, you see basically a text generation model. It can be any text generation model like PaLM or GPT-3 or any such model generating some large text. The marathon world record is something and so on, right? Now, research and revise is exactly this model, which basically takes the output of any large language model and then tries to revise it. So for example, in this particular case, the model actually takes the wrong record timing and essentially tries to correct it out. Also, it corrects out the old date in 2018, 2022. Right? It does so by using retrieval augmentation. So by using an external knowledge corpus, a document corpus. While revising, it also generates an attribution report. So why does it believe that this timing is the correct one and the previous one was the wrong one? It basically provides evidences and up to a maximum of 5 evidences. Now, of course, after you revise things and you create the attribution report, how correct those are. So as to evaluate those, these folks also can come up with two different metrics, attribution score and preservation score. The attribution score sort of identifies how much of the revised text that you created can be attributed to the evidence that is there in the attribution report. And the preservation score sort of tells you how much the revised text Y preserves the aspects of the original text that was generated by the large language model. And thus RARR is a retrieval augmented model where the retrieval actually happens after the generation rather than before the generation. Right? So it's not retrieval augmented generation, but it's like retrieval augmented generation, which happens after the generation from another large language model. Okay. Now, how do you measure attribution and how do you measure preservation? Well, to measure attribution, they define the metric at the sentence level. So at sentence level, you compute something called as AIS score, which is attributable to identified sources score. This AIS score essentially just checks for like exact matching things. So do the words or n-grams basically match exactly as mentioned in the source sentence? Now this is a binary score, so 0 or 1 at the sentence level, and therefore when you combine it across different sentences in the overall output that is generated, revised output that is generated, you get the average score. So it basically tells you how many sentences match between the revised output and the evidence. Well, you can compute that using a human way, like ask a human annotator to do that, or you can actually also do that in an automated way by treating natural language inference models, as a proxy for humans. So natural language inference models are models which basically take two sentences, hypothesis and the premise, and then basically figure out entailment or not. So that's that. Preservation is basically done using two scores. So one of the scores is about preserving with respect to character by character match in terms of Levenshtein distance. So essentially it tries to figure out the Levenshtein distance between X and Y, where X is your original output and Y is the revised output. And then it basically computes the preservation score in terms of the Levenshtein based character based preservation score in terms of this formula, which basically, says that, hey, if there is a complete match, then the Levenshtein distance is going to be 0, and therefore you will basically give the score as 1. Right? So on the other hand, this Levenshtein distance does not really capture intents, so it does not really capture if style or structure is being preserved and so on. And therefore, they also have a human way of computing this preservation of intent score, and you multiply the two so as to get the combined preservation score between X and Y. In both the cases, whether it is for attribution purpose or for preservation purpose, the annotators were also given surrounding context, not just the particular sentence that you're interested in, but also the surrounding context to measure the attribution and preservation more accurately. So how does RAR work, right? So how does this research and revise model work? Let's basically start from here, from the picture. So you have the input passage X, and you have to basically revise that. And here is our final output. This is basically the revised output, where as you notice, the location, the venue is not really changed. But if you look at the date, that is basically changed from 24th February to 1st October 2014. Right? So the way this works is as follows. You have several stages. So in the first stage, you take the query and you have two stages. One is called as the research stage, and the other is called as the revision stage. So I'll talk about the revision stage on the next slide, but let's first talk about the research stage. So in the research stage, in fact, there are two steps: query generation and evidence retrieval. So you take the passage X and you're trying to basically generate all kinds of questions about different aspects of this text. Okay, so essentially, for example, when did this particular movie premiere, or what channel was this movie on, right? This movie or this show on, right? So you ask this, you raise questions, and how do you generate questions? Well, you generate questions using a large language model itself. In their particular case, they use Palm 540 billion as a large language model, using which you do query generation with 6 exemplars. So in most of the stages in RARR, a few shot 540 billion Palm model is used, right? So few shot basically means you give exemplars as well, along with the prompt, along with the task instruction, right? So that's that. So query generation basically gives you, for example, some n queries, 2 of which are shown here. Now, after that is done, you basically try to find evidence. So that is called as the evidence retrieval phase of the research stage. You find evidence. In their case, they found evidence using Google. So you just take the top 5 web pages. From those web pages, you extract windows of 4 sentences, and then you rank those windows using relevance based on a T5 large model. Right, so basically, and then in their case, they pick one evidence per query, right? So one evidence per query. So if you had n queries, you would basically end up with n different evidence 4-sentence evidences, right? So in the revision stage, so further, once you get the evidence, you basically, in this particular case, 2 evidences are shown. So you basically ask, you have an agreement model in place, which basically tries to figure out if there is this evidence and there is this input passage X, do they agree or not? Given this question. Okay. Similarly, you ask for the other evidence. Hey, given this passage X and the evidence and this question, is there agreement or not? Right. So if there is agreement, then you don't touch that. You basically pass that as the final output anyway. But if there is disagreement, you essentially try to edit this output, and then you try to edit based on the evidence. So you basically take the 1 October 2014 from here and you pass that as the output. Of course, the overall output is a combination of these two, which is finally generated by passing the in between, by taking the revised output from the edited evidence and passing that to the next one. Okay, so this part is sequential in some ways. The output generation part, I mean. In general, when you have these evidences, of course, you select top few of them and then put them as part of the attribution report. I'll talk about them in detail in the next slide. So in the revision stage, as I talked on the previous slide, there is agreement model and edit model. Agreement model basically takes input as the partially edited passage Y, the query Q, and the evidence E, and tries to figure out whether they agree or not, right? Whether Y and E agree or not, given the question Q. Again, the agreement model is also a few shot prompting PALM model, but this time also uses chain of thought prompting. So if the agreement is not there, then the edit model is called. And the edit model, of course, takes your partially edited passage Y, the query Q, and the evidence E. And then it outputs a new version of Y, an edited version of Y that aims to agree with E, while, of course, minimally changing Y, right? Minimally altering Y. Again, they use few shot prompting with chain of thought. And while doing the edit, sometimes weird edits can happen. So to reject edits, so therefore they reject edits with edit distance greater than 50 characters compared to the original text length. Okay, so once all the edits are done, attribution report also needs to be generated. Now you may have many evidences, like 100 evidences for that matter. I mean, not typically 100 because you can't really generate too many questions. But you have too many evidences. Now, but then, evidence report needs to be short so as to be readable and understandable by folks, by users. And therefore, they create an evidence report, an attribution report combined out of evidences by choosing maximum 5 different evidences based on relevance. So the relevance model, again, that they use is the T5 large model, which is also the model that they use in terms of deciding whether an evidence is relevant or not. Okay. So on the right side, you see for each of the models that we discussed as part of RARR, query generation, agreement model, and edit model, all 3 of them, of course, are just few short prompting based PALM models. In query aggregation case, it is basically not chain of thought, but in the other 2 cases, chain of thought is also used. These are basically the prompts that you can see. So you said something, and then to verify it, there are these evidences, and or that to verify it, these are the outputs. So the red colored part shows the outputs, the blue colored part shows the inputs, right? So these are the questions that are generated to verify if this particular output generated from a large language model is correct or not. Right? Similarly, in the agreement model, this part is the output, this part is essentially the question, this is the evidence, and then the model has to basically mention whether it agrees or not. Okay? It agrees or not. Basically, the evidence that is generated, the evidence that is found, basically agrees with the original Y or not. Okay? So the edit model basically tries to edit. If there is no agreement, edit needs to be done. So there it again takes those same YQE triple and then tries to come up with an edited output. So how does RARR perform? Well, the research and revise model is awesome, as we will see in this slide. So they performed experiments on 3 different data sets: natural questions, strategy QA, and QREC. QREC is a dialogues data set. Natural questions is a question answering data set, and strategy QA is a reasoning chains based data set. Right? So you basically give various inputs to large language model. It could be GPT-3, it could be PaLM, it could be Lambda, whatever it is, right? And you basically get outputs. So here are the outputs that are shown. So PaLM model outputs on natural questions. So this is some output about a question answering problem. This is PaLM model output on strategy QA. And then there is also some output about from Lambda. So Lambda is basically a dialogue model, and the output here is just the last sentence. But then, and this part is basically the input, in fact, not the output. Just the last sentence is the output. But then when giving input to the RARR model, well, in general, you give for factoid statements and reasoning chains, you just give the output of the large language model as input to RARR. But in case of Lambda, you also give the entire dialogue as the context. And therefore, you give the input and output, which was given to Lambda, as also input to RARR. Now, what you see here is the result of doing all this in terms of attribution and preservation. And it is basically RARR is being compared to 2 other models, EFEC and Lambda. EFEC is basically a T5 based model where you essentially say, hey, this is the output generated from some model, try to edit it and make it perfect. Yeah, I mean, essentially try to preserve stuff while improving on attribution as well. Right. So what you see here is that auto AIS and AIS scores both are reported. Also, what you see is the preservation in case of preservation, intent and Levenstein score both are reported, and the combination is also reported. The simple multiplication of these two, right? Finally, F1 score is also reported, which is a F1 computed over attribution and preservation. So everything is between 0 and 1, or rather between 0 and 100. So that makes it easy to compare. So what you see here, so in auto AIS and AIS, these scores basically show you how much was the attribution for the original output X versus how much is the attribution for the output generated after modifications done by RARR. Right. So what you observe is that in all of these cases, if you compare with EFEC or Lambda, both of those baselines, in all of these 3 data sets and outputs generated by PaLM and Lambda, you observe that RARR has significant improvements compared to any of these, compared to Lambda and EFEC. Okay. So this is a case study on the right side to show you how Lambda and RARR perform, right, versus EFEC. So here's the input. Justice Ashok Kumar Mathur headed 7th Pay Commission in India. It was created in 2014 and submitted its report in 2016. Now, 2016 is a wrong year here, and RARR nicely corrects it out. It basically has 100% attribution with respect to this evidence, which is shown at the bottom, and it also preserves the style and structure and the character-wise stuff also reasonably well. Right. While on the other hand, if you look at EFEC, it just reduced the entire thing into a single sentence, preserving hardly anything. Also, if you look at Lambda, it doesn't preserve much of the stuff. They start talking about some minimum salary and so on, rather than actually talking about Justice Ashok Kumar and so on, right? So that's that. Now, on the left bottom, you see this picture which shows you on the x-axis is preservation, the y-axis attribution. You see these 3 charts for 3 different data sets and 3 different experiments that were done. So natural questions data set, strategy QA data set, and this QREC data set for dialogues. So these are heat maps which show you how do these 3 methods perform. So there is, of course, preservation and attribution, and then these contour lines basically show you wherever the F1 score is the same. So F1 is harmonic mean. So on a single contour line, the F1 score is the same. So the dotted line basically shows you that if you are using the standard output that comes from these PaLM model or the Lambda model as is, without doing any RARR or any kind of attribution or preservation correction on top of it, right? what you see is that these models generate stuff which has low attribution scores, right? So in case of natural questions, it is some 37% attribution and so on, right? So what you observe is that across these three baselines, you observe that the blue one, the RRR one, actually has significantly awesome preservation, right? So 75% plus here, 85% here, and again 85% here, right? So preservation scores from RRR are pretty good. And also what you see is attribution scores are better than the original output generated by Palm or Lambda, which is so nice because it is above the dotted line, right? On the other hand, if you look at Lambda, well, in case of natural questions, its attribution score dropped, right, which is too bad. Also, what you see is that these green and the red dots are very much closer to the left side, which basically means that they're hardly preserving the original output generated by the large language model, right? So therefore, RRR is an interesting and a nice model which can increase attribution by up to 13% absolute, right? So 13% absolute points compared to this dotted line, while changing only 10 to 20% of the text, while keeping the preservation to about 85%. In summary, in this video, I talked about RARR, which is a framework for revising claims from large language models to make them attributable to the researched evidence and therefore reduce hallucinations. RARR can revise the passages to improve attribution while preserving other desirable properties such as writing style or structure. RARR, the nice part about RARR is that it does not really mess around with your original large language model. You can run your large language model as it is, but RARR sits on top of this existing large language model without needing to redesign or retraining your large language model. That's it. Hope you liked the video. Thank you for watching. Connect with me on my LinkedIn or look at my research on my homepage. Thank you.